should always be written in capital. And it simply means analysis of variance. It is a statistical technique that is used to analyze continuous interval data. There are several stages, or there are several stages, types of ANOVA. This is the simplest form of it. It's referred to as the one-way ANOVA. And we use it mainly to analyze factorial data that are in the form of factorial designs. Factorial designs, like you were taught in experimental psychology, are simply you have one or more independent variables with two or three levels, and then one dependent variable. So we are going to do a simple exercise using the one-way ANOVA or related, the simplest form of ANOVA. Before we start, we are going to find out, or we are going to answer this question. When do you use the one-way ANOVA or related? We use the one-way ANOVA or related when we are trying to analyze data obtained from different participants who did 3 or more conditions, testing one independent variable, and the data obtained from them are interval. Let's take a research hypothesis. It's on record. An experimenter predicted that 3 presentation rates of list of words would have an effect on recall. An experimenter that 3 presentation rates of list of words would have an effect on recall. If you have to put that in a hypothesis, you say that presentation rates or you can put it in this form. Word presentation rates would significantly have effect on recall scores of students. I have recorded that to a hypothesis. What presentation rates will significantly have effect on recall scores of students. And where is the independent variable here? The independent variable is word presentation rate. While the dependent variable is recall scores of the students. Now, using this hypothesis, this hypothesis is in what form? It's in the alternate form. The hypothesis is in the alternate form. If we want to make it to the null form, we simply say what representation rate would not significantly is in the negative and the of no effect and of effect. Now, let's generate a set of data to test these hypotheses. I hope you will remember the hypothesis later. If you didn't copy it, or you will not remember it, I am sorry. We already have it on record, you can go back to it. Now, we have three presentation rates for the words. We have condition 1, condition 2, and then condition. Sorry, I'm writing the conditions in application. And the presentation rates are slow rate, medium, and fast. Remember, we are dealing with unrelated design, and these are the scores obtained from the participants. What scores did we obtain? Recall scores. Let's work with this. Now, these are the scores the experimenter obtained. These are just sample scores. We just generated them. These are the scores that the experimenter obtained for each participant's record. When the ones were presented at slow rate, this is what the participants scored in terms of what they remember, the number of words they remember. At slow rate, this particular participant, let's call her Anne, record 8 words. While John record 7 words, Anthony record 9 words, and so on and so forth. When the presentation rates were medium, these were the scores obtained by different categories of students. So each score here refers to the record score obtained for each student in that category. So students in this category, in this condition of the experiment, were not participants in this condition because we are using unrelated design. I hope you understand me. Unrelated design. Now, we can calculate this to get the total. The total will be referred to as T. So let's get the total here. The total here is what? 40 on the plane, And the total here is what? 37. Please confirm whether they are right. And the total here, 24. Confirm. Then you can calculate the means. The means, we can say the 1. The 1 is what? For 3 divided by 1, 2, 3, 4, 5, 6. 7 point. 7 point. How did it get to 2? 7 point what? 166. It's 7.17. Don't be in a hurry to 17 will be better. 7.17 will be better. Then here, 37 divided by 1, 2, 3, 4, 5, 6 will give us what? Mean 2. Will give us what? 6 point. Is that correct? Yeah. 24 here will give us what? And 4. Just 4. Mean 3. 4. Okay, now we have a grand total. We usually calculate the grand total. The grand total refers to all these totals summed together. 43 plus 37 plus 43 plus 37 already will give us 80. Plus 24 will give us what? 104. So the GT is equal to 104. Now we have to calculate with this table and with this data set, we can do a step-by-step calculation of ANOVA, one-way ANOVA unrelated. Please, I want you to pay attention. This will take us 7 or 8 steps. 8 steps. So you have to pay real attention for us to get there. So the GT is 104. So I want to split this board so that we can catch up easily. So step 1. For step 1, we are going to calculate the symbols. To get familiar with the symbols. So step 1, symbol. So for the symbols, we have summation T squared. Summation T squared refers to the sum of squared totals for each condition. The sum of squared totals for each condition. What we simply means is that summation T squared is equal to 4(3) squared plus 3(7) squared plus 2(4) squared. And that gives us what? What does that give us? Sum it now. 4(3), use your calculator. Just say 43 squared. You can calculate it together. Leave 1,000. 3794. Are you sure?
Yes.
Okay. Now we calculate the next symbol. Very easy. You still understand? 1. The next symbol is N. Number of participants in each condition. Very easy. For each condition here, we don't have problem. It's all related, so they are balanced. So we have 6 participants. Then the large case N. N here, total number of scores. What is the total number of scores we obtain? We have 6 times 3. That equals what? That gives us 6 times 3. Why is it difficult to say? So 18. Then we have another symbol, summation x all squared. The grand total squared. The grand total squared. The grand total. What is the grand total? 104. So it will now be 104 squared. And that will give us what?
10816.
10816. Is that clear? Then summation x all squared divided by n is equal to the constant subtracted from all sums of square divided by n. We already calculated this, and that is 10816 divided by, we already calculated n, which is what? 18. And that will give us what? That will give us what? 600. So people like 100. 600 point 89 what? It can't be either. Mathematics is not either. Two decimal places. You should know that we are doing two decimal places. We have been doing two decimal places all this while. So why would we do 89? So that is step 1. Okay, we will conclude the last stage of step 1. Summation x squared, and that is the sum of each individual score squared. The sum of each individual score squared. So summation x squared is 8 squared plus 7 squared plus 9 squared I will send somebody out to you. And it's going to be fun. 8 squared plus 7 squared plus 9 squared plus 5 squared. You continue up to 4 squared. Add all of them irrespective of the rows. Please do that quickly and give me the result. Do the calculation. What did I say you should do now? What did I say you should do? Add all of them. Use your calculator to add it. They are all in the what? 8 squared plus 7 squared plus 9 squared plus 5 squared plus 3 squared plus 8 squared plus 7 squared. Continue up to the last one.
42k.
What are you doing? I'm your own and keep quiet. When I call for the result, you tell me.
I'm like, how did you get 319?
Okay, what did you get?
319. How? 664. You're scoring everything.
Please, listen attentively. Listen attentively. It's very easy. Simply add all this. the square of each of these. Continue from here, from this point to this point to this point as one unit. That's why what I showed here, plus continue up to 4 square. The last number there is 4 square. What did you get?
664.
664. Is that agreed? So that was equal to 664. Okay, now we have finished step 1. So we go to step 2. Remember, we said we have step 2. Step 2 is to calculate this between sum of square, what we refer to as SS bet, the between sum of square. To do that, we use this simple formula: summation t squared divided by n minus summation x all squared. That is the constant now. This will be featuring mainly in our work. Please take note, at this stage, where you are going to do a lot of raw calculations to get what you use for the other subsequent steps. So at this stage now, you know what is summation t squared. See it here. Are you getting me? Yes. So you simply put it 3794. You have to be careful, because if you are wrong at any point here, everything you are doing will be wrong. 3794 divided by 6 minus, we already calculated the constant, minus 6.
You know 6 is 4.
See the constant. This is the constant. Don't stop thinking. Look.
Brackets.
See what we have here. Summation x all squared divided by n. Summation x all squared divided by n. We said summation x all squared is 104 squared, and we got 10816 divided by n, which is 18, and we got 600.89. There's no point here. 600.89. And that is what it is. It's not a matter of thinking. So do this arithmetic. Do this. 3794 divided by 6 will give us what? So SS bet equal to what? Which n? We have already done that. See it here now. Which n are you looking for again? Which formula? This formula.
Yes.
See it here. See the result.
Okay.
Are you understanding me?
Yes, sir.
So SS bet is equal to
632.33.
6. Please. We want an organizer. Let us hear from you. Let's hear from you. Yes, you. Wait, keep quiet. I pointed somebody. Stand up. Six 33.32 minus 600 600.8.
Yes. So after the decimal place, you count 6.
Please, what is the confusion?
Like 632, not 633. No, not the decimal.
Please, divide this by this. What did you get?
632.33.
Is that what you got?
Oh, mama.
Why did you give us 633? I will start showing your faces in this camera. Take it. Nobody has been. Go and meet.
Who is the person?
Cameraman. Go black.
6 point. And what again? When you now subtract 632.33 minus 600.89, what do you get?
1.44.
3 1 point. So SS bet, that is the between sum of square. The between sum of square, SS bet is 3 1 point what? Okay, we go to step. Please remember all this. If you forget it, so step. We have how many steps more?
Step 3 now.
5.
5 steps. Eh? How many steps did you say this is?
Yes.
Okay.
Repeat to me, sir.
Step what now? I mean, calculate the total sum of square. We use this formula. Summation square minus constant. And that will give us, we have already calculated this before. What did we calculate here? 6 is point, any point? No. Minus 600.89. So SS bet is what? SS, total sum of square is now what? 63.11. Any confusion? Ask your question quickly. Speak up, speak up. If you cannot speak up, don't ask questions. Yes? Ask your questions, you are free.
So somebody said yes.
But you must speak up. Everybody must hear you. Step 4. No question. Somebody wanted to ask question. I said speak up. Stop. That means she didn't want. She wanted to interact with me. And she wanted to interact with me. It's not a personal discussion.
Every day, every day. How would I tell you? Hey!
They follow that.
So, listen, for in case you get confused, listen. We have already calculated this when we are calculating symbols. This was what took us so much time. 8 squared plus 7 squared plus 9 squared plus this plus this plus up to this. That is where we calculated this. And that's what gave us 664. Check your book. Eh? Then this is the constant. We already have it. It's constant. No change. We already have it. That's what you did this. And we got this result. Now step 4. We will calculate the error. The sum of square, the error sum of square, that is SS error. That's very easy. SS total minus SS bet will give us SS error. Where SS total is 63.11. The between sum of square is what? 31.44. And that will give us what? That will give us what? So the graph freedom between is number of conditions, minus 1, which is how many conditions? 3 minus 1, 2. Then the graph freedom total is number of minus 1. That's n minus 1, which will be 18 minus 1, which will give us 17. The graph freedom error is the graph freedom total minus the graph freedom between. That's the between sum of the graph freedom. And that will give us 17 minus 2. And that will give us 2. So these are the degrees of freedom. Have you got this? Okay, we can progress. Step 6. Step 6, we will calculate the mean squares. Step 6. To obtain mean square, divide each sum of squares by degree of freedom. That is the simple formula. To obtain mean square, divide each sum of square by degree of freedom. And we are going to obtain the mean square from the between sum of square, the mean square, ms get, and then we'll obtain mean square for ms error. The formula is straightforward. Is ss divided by df bet, and then for ms error is ss error divided by df error. We have obtained all this before now. Those of you copying notes, watch what we are doing. Understand what we are doing. It's very important. What is SS bet? What is the between sum of square? What is the between of both? 31.44 divided by the degree of freedom between. That is what? 2. And that gives us, that will give us what? 15.72. That is our between means the sum of the mean square between. Then for this we have SS error is what?
31.67
divided by the DF error is what? 15. And that will give us 2 point. And 31.67 divided by 15. 2.11. Step 7. Yes. No. You are not leaving.
What is it?
You will soon run.
I swear, I don't even know where. And this far, it's
Now, we go to step. I hope we have all these course. Okay. I just gave you time to pick them up.
you go past.
For step 7, what step are we in now? So we these are my step 7. At step 7, you didn't get a seat. Don't sit there.
Sissy girl.
At step 7, we calculate the F ratio for NS bet over MS error it is the F ratio that we are looking at. So the F ratio for MS MS bet over MS error.
What does the F stands for?
The F
Yes.
F values are something that is related to ANOVA. I've actually not asked this question before. I've not been asked, but for every ANOVA, we are seeking to calculate the F value. Just like for a window. What are we calculating? What are we calculating? The U value, the U and the U prime. For T test, we want to obtain the T. The same thing for ANOVA. We want to obtain the F. Larger F values simply imply the possibility that our data will be significant. But there's no guarantee for that, but most times it yields more significant values. So to get our F ratio or our F values, we say MS bet divided by MS error. We have done that before. What is MS bet?
15.7.
15.7.
Is MS bet is what?
15.72.
15.72. MS error is what?
2.1.
2.11. And that will give us so our F ratio is 7.45. Beautiful. Now, this is how we write it now. We write it in this form. F at degree of freedom 215 equal to. Where did we get degree of freedom? Please go back to your data. Go back to your calculation. Where did we get degree of freedom 2?
N minus 1.
Where? At what point did we get degree of 2? We got all the degree of freedom in one point at one step. At one point.
Step 5.
No, we all got it at step 5. What I mean, at what point?
The total number of
It's there in your paper. It's not something you calculate. Eh?
Degree of
Let us hear her. Eh?
Degree of freedom between
Degree of freedom.
One.
Degree of freedom between. And at what do we get 15?
degree of freedom
Error. We are simply saying the F at degree of freedom between degree of freedom error is 7 point. Are you getting me? That is what we are saying here. This is how the F values are written. I am sure you must have seen journal papers when they write things like this. Eh? You must have downloaded journal papers. You will see things like this. You'll be wondering what it is. The F value is at degree of freedom 2, 15, and this is what we obtain. And then we will learn more about it now by checking. So this is our F value. This is what we calculated. This is our ANOVA. This is what we arrived at. Because in ANOVA, what we are targeting is to get the F value. Now, the next thing for us to do is to look up the significance at of F in table G. Let's look whether F is significant. Go to table G1 and G2. Table G1 and G2 are the appropriate table for ANOVA test. G1 will give the values at 0.0 and P is less than 0.05, while G2 will give it and P is less than 0.01. So we are using G1. The decision rule as written on top of your table there is that the calculated F has to be equal to or larger than the values in the table. You need to use the degrees of freedom for the between condition variance and the error variance. Go back to step 5. You need to use those degrees of freedom to check it. So the degree of freedom between is 2, like we found out recently, and the degree of freedom error is what? 15. So in table G1, the degree of freedom between is shown along the V1 row. Are you seeing it? V1 row.
Yes.
And the degree of freedom error is shown down the V2 column. The column. Have you seen them? Now marry 2 degree of freedom between with the DF error of 15. What do you get?
3.68.
Beautiful. Who hasn't got 3.68? F215 critical equal to 3.68. Who didn't get 3.68? Use your table. That's why I insist. Where's your calculator? Use your table. I read this instruction on how to get it. Please, if you are confused, you can consult. I've asked questions. Nobody answered. You can confuse with your coursemate. Now, the next step is to see whether our calculated value of is larger than the critical value. Is it larger? Why are you saying no? Are you with us here? Yes. Is 7.45 not larger than 3.68?
It's large.
Then why what you know for? Now, what do we conclude?
It's not
The null hypothesis can be
so
rejected. When we say the null hypothesis can be rejected, we are simply saying that there is a significant. We said the decision rule. We mentioned it here now. That the decision rule that the calculated F has to be larger than table value, the value on the table for it to be significant. Now, this is our calculated value. It is larger than the degree of freedom 2 and 15. This is what we got. What we calculated, this is what we got. So this is significant. Are you with me? Simple. Now, we have. So, assignment. You will key. I think we can end our video so that I can give.